So without further ado, since we all know Bonnie, I will introduce Bonnie Witzgall, who will give her presentation on astronomy down the shore.
Okay, folks, you can hear me, I hope?
Yes.
Okay, good. Okay. Oh my goodness, this is going to be crazy. But, okay. Good evening, everyone, and thank you for Zooming. I can't see any of you right now, but that's okay. I don't want to lose the signal. So, when I ask a question, let's see a show of hands. How many people are going on vacation to a seacoast or an ocean or a seaside resort? Raise your hands, or have been to the ocean or have been to a seaside resort. I hope a lot of you. Okay.
Yeah, yes.
Those of you who have been to an ocean on vacation, how many of you have done astronomy when you were there? I hope some of you.
No.
Okay, please change. Okay, next slide, because it's very easy. No, right there. Because it's very easy to do astronomy when you're down the shore. You just have to know where to look. Okay, next. This planet is covered with 70% water, or I should say the surface is 70% of the surface is covered by water. And I think Arthur Clarke was right. We call this place planet Earth, we should call it planet Ocean. Okay, next. This is what's happening tonight. We'll be talking about planetary geology and word origins and tidal differences and weather and planetary storms and ocean storms and solar storms and measuring time by the sun and all kinds of things you can do for astronomy when you are down the shore. Okay, next. If you go down the shore or anywhere along the seacoast, it's a perfect place for astronomy. There's plenty of astronomical places of interest all along the shoreline. You just have to know where to find it. And whether you go down the shore or not, we're always astronomers. We're constantly observing. We're always doing science, even on vacation, even when it's cloudy. My God, think about the people who wanted to go down the shore this weekend. Okay. First of all, if you get wet in the ocean, you could be bathing in cosmic water. There's one theory that says the oceans of Earth were created by water-bearing comets billions of years ago. Now, that's just one theory, but it's a very interesting theory. And you could be getting wet from cometary water. Next. Now, you know it's a long, hot summer. It might be a long, rainy summer, but it's also a hot summer. The northern half of Earth is tipped toward the sun during the summer, and the northern half of Earth is tipped away from the sun during winter. So the northern half is tipped away in winter. That's why it's cold by us. And in the summer, it's hot by us because we're tipped toward the sun. Next. Earth is actually closest to the sun during the northern hemisphere winter time. So we get more sunlight in the winter than in summer. You may not feel that in the temperature, you may not see that when it snows, but we do get 7% more of the whole Earth in winter than in summer. Next. I don't know if you've ever noticed this. You can notice this if you take pictures of the sun every couple of days during the 4 seasons. But the summer is higher in the summer sky and lower in the winter sky. Therefore, when the sun has more time in the sky, it's hotter, which is what happens in summer in the northern hemisphere. And when the sun is lower in the sky in the winter, there's less sunlight that hits the surface of the earth, which also makes it colder in the winter, less sun, and warmer in the summer because there's more sun. And it's the same way in the southern hemisphere. In their summer, the sun is higher in the sky. And that's why, if you look at it from our vantage point, the sun is lower in the sky. And it's sort of halfway all year round at the equator. I hope you understood that. That's been a crazy day. Okay, next, please. Next. Okay, ultraviolet. There are certain rays that are not stopped by the Earth's ozone layer. And it can cause a lot of damage on your skin. Next. Too much sun will give you a bad sunburn or skin cancer or age spots or cataracts. And if you think you tan wonderfully, it's just your way of the body's attempt to protect itself from the sun's harmful rays. Getting a good tan is not a good thing. That's why you need sunglasses and glasses or contact lenses or sunscreen or a broad brim hat to protect yourself from the sun. Okay, next. And of course, we have a G-type star. The sunlight and its heat reaches Earth every 8 minutes, 20 seconds. It can get really, really, really hot, especially by an ocean, because it's reflected off the sand and the water and the asphalt and the concrete. Not only can it burn your feet when you walk on hot sand, it can also burn your skin everywhere. So try and stay cool. Next. Okay, this is very interesting. Seaweed helped astronomers to see. Turkish glassmakers made their way to Venice and then to the island of Murano. They were isolated, so they created their own experiments and trying to make different combinations to make glass, not only lenses, but also decorative things like that, see? Eventually, seaweed was used to produce ash with a high content of potassium oxide and manganese. And when this was added to molten glass, Murano glass was invented. And it was more transparent than anything else that had ever been produced. Next. Here you see seaweed or kelp being collected and burned. They're making the seaweed into soda ash, which is still used today in making soap, bleach, pottery, and glass. Next. You have to celebrate that seaweed. You think seaweed is yucky and slimy, but no, no, no. It led to better optics, and therefore it helped astronomers to see better. So you celebrate that seaweed. Now, you can also tell time down the shore by just putting a stick in the sand and putting shells or stones all around, and you can make your own natural sundial. And it proves that Earth rotates and orbits around the sun. A long shadow means the sun is rising or setting. A short shadow means the sun is overhead, which is solar high noon. And if you make your own sundial with a stick and some seashells, it's very biodegradable. You just pick them up and throw them back in the ocean and start over the next day. Next. Time and tide. You have a spring tide and a neap tide. It shows where the gravity of the moon and the sun are pulling on the oceans of Earth. A slight variation in the gravitational attraction will produce different tides at different times along different sea coasts. And I'll get to that in a few other slides. There you go. semi-diurnal. Let me make sure I pronounce that right. Semi-diurnal, which are 2 high tides and 2 low tides on a very straight seacoast. From one area of the high tide, the water is pulled outward, and then through an area of low tide, and then it goes through an area of high tide again, and it's pulled the opposite way. So you have a high tide and low tide. And if you look at the little illustration, that horizontal line, it's hard to see, but that horizontal line actually represents a nice, smooth, straight coastline. It's when the coastline goes very deep inland that you get weird tides. Okay, next. Yeah, see, if you have a nice straight coastline, you have 2 high tides and 2 low tides every 24 hours or so. That's during a semi-diurnal tide. And you see the illustration. Okay, now. Yeah, that's fine. Next, right there, stay right there. The landscape affects the tides. A straight coastline, like I said, changes every 24 hours, but a wavy coastline changes every 12, and a deep coastline that has a lot of variation changes every 4 hours. A lot of places on Earth have very deep channels or narrow inlets. It's not just the depth of the channel, but how far inland it goes that will affect the tide cycle. Next. Like I said, the landscape affects the tides. The shoreline is shaped by rivers and waves and tides, and the different coastlines will generate extreme tides, or what we would say normal tides. But the extreme contours of the coastline will make weird tide cycles. Okay, I have an illustration coming up for that next. Right, well, there are many other places on Earth that have extreme tides, but the Bay of Fundy is the most famous, let's say. It's from the French meaning split. Some people think it's from the Portuguese meaning deep. Guinness Book World Records said this basin in Nova Scotia had the greatest tide range, 47.5 feet, and an extreme range of 16.3 meters. This is the most famous. There's another one in Great Britain, but this is the most famous. And you can go and visit that. I'd like to do that someday. Okay, next. Okay, just stay right there. It has a narrow, shallow inlet. And it has 2 high tides and 2 low tides, but its shape creates a very severe tide 2 times a day. Okay, next. Now look at the picture of the boat next to the dock, and there it is. When the tide goes out, the boat goes down. That's gravity. But that's how extreme the diurnal tide is in this narrow, shallow inlet. Okay, next. Now, atmospheric dynamics, also known as weather. Changes in the ocean temperature affect the weather patterns around the world. The Fujiwara effect shows 2 storms moving around a common center point. I hope you are never down the shore when you have to fight with 2 hurricanes like this. They move off together while still locked in rotation. And if you're on land underneath them, oh, good luck. All right, hit the button again. And there it is. Atmospheric dynamics is also called weather. I just put that in 51, just to show you. I had 2 hurricanes locked together. I just wanted to show you 2 galaxies locked together. as sort of a comparison. Okay, next. Cloud formation. We have clouds all over the place, not just on Earth. They are condensed droplets suspended in the atmosphere above the surface of land or water. Especially now, they're suspended over land. But they're all made of the same thing, whether they're on Earth or on Venus. They're all condensed water or ice. And okay, cyclone formation on Earth. Now look at that. We got four storms in 2004. Oh my God. But they're all driven by the sun's heat. Fueled by heat, when moist air rises and they condense and the water vapor drops as terrible rain like we're having now. Now that's an Earth cyclone, okay? And it's driven by the sun's heat. Keep that in mind, please. Next. People think that the storms on Jupiter are hurricanes or cyclones, but they are not, because the ones on Jupiter are not driven by water. They're driven by the heat within the planet. And of course, Jupiter radiates more than twice as much energy as it receives from the sun, which is sort of interesting. There's water in Jupiter, but not enough to create cyclones like we have on Earth. And that goes for any other storm on other planet, like the spots on Saturn or the great dark spot on Neptune. They're all driven by the heat within the planet, not by water. Okay, next. Aurora. Wouldn't it be wonderful to be down the shore or at a sea coast and watch aurora? And wow, that's from the Earth's magnetic field, which protects us from solar flares. They're made of charged particles which follow the Earth's magnetic field, and when it reaches a certain point, it snaps back, releasing red and green light. Sometimes you can get white. Sometimes you even get pink, depending on the chemicals in the atmosphere. Okay, next. Other planets have aurora. It's not just Earth. You have them on Jupiter, and you have them on Saturn. You even have some on Venus and Mars. Mars has aurora around its equator, and nobody knows why. And Mars is not talking. But aurora can happen. There you go. Oh, that's fine. That's fine. Aurora can happen on all the planets, not just us. All right. Now, storm formation. Stormaz, which means noise. A storm is any disturbed state of an astronomical body's atmosphere affecting its surface. They're caused by strong wind, thunder and lightning, heavy precipitation, or wind carrying some substance through the atmosphere. And we experienced a lot of that in Vermont, believe me. But it just doesn't happen in Spain or Vermont. Here's an example of a storm on Neptune. Okay, next. Lightning. Plenty of thunder and lightning. You can have it over Florida, you can have it over Venus. They are electrical discharges from cloud to cloud or from cloud to ground. I'm sure you've all seen lightning. It's very breathtaking to see lightning over the ocean. It really, really is amazing. And loud too. Okay, next. Lightning storms. They come from cumulus thunderclouds. Anvil-shaped masses. They can reach 40,000 feet or more. They occur on any planet that has wind or humidity or friction and atmospheric pressure. They occur on any planet that has the impact of solar wind and an accumulation of charged solar particles. So you can blame the sun for the lightning. Okay, next. It's not just Earth. Jupiter. Jupiter has lightning storms too. And this happens to be on the night side of Jupiter. And they were able to get these photos. They didn't expect to see anything on the night side of Jupiter. They expected to see dark because the sun wasn't shining there. And all of a sudden, they got these blips. And the NASA scientists realized these were lightning storms. This was a great revelation. Okay, next. And there's some more. Jovian lightning. And it looks like I didn't finish that. Okay, the sun heats the Earth equator more than the poles. So lightning is at the equator. But in Jupiter, the sun heats the poles more. That's why you've got lightning on the poles instead of at the equator like we have on Earth. Well, I guess I'll have to edit that slide. But okay, next. Now, seas. If you're down the shore, did you ever look at the moon? It's beautiful. And of course, if you're down the shore, you're next to the ocean, or you're next to a sea. So we have to discuss lunar seas. Of course, they're not seas. There is no water. Ancient peoples thought the moon was covered with watery oceans in the dark areas. But what they really are dark basaltic lava flows, creating a smooth surface, which I suppose could appear like water. Of course, they form shapes too. And that's why people think they see a face of the man in the moon.
I see the cow.
And next. Yeah. Next. And right there. Okay. When you are at a seacoast, ever see the moon rising or the sun rising or the sun setting? They look orange or they look red because they're filtered by the Earth's polluted or smoky atmosphere. And that cloudy atmosphere creates a lot of coloring effects. And I'll explain that in a minute. Why? Right there, see, colored moon on the horizon. The moon appears to be different colors on different nights and against different ocean backgrounds. And why is that? Okay, next. Because it's an atmospheric trick. If you are looking at the moon when it rises, you're looking through a thin atmosphere. No, the other way around, I'm sorry. You're looking through a thick or thin atmosphere, which distorts the moon color. If you look at the moon up above, you're looking through over your head, you're looking at less atmosphere and less color. But if you're looking at the moon as it rises above the ocean, you're looking through more atmosphere and more color. So you get like a filtered effect. All right, next. You can do astrophotography. It's wonderful. You have no light pollution, no city skylines, no people to bother you. You can do astrophotography. And you can get photos like this as the moon rises above the water. Okay, next. Planetary geology. It's very easy to do planetary geology when you're on a seacoast. You just look at the sand. And you would do the same thing if you were walking around the surface of another rocky planet. They're always altered by wind or waves or sand blasting. And you can learn a lot about just looking at the sand and the dirt and the cliffs wherever you go. All right, next. Sea sand composition. We have it on Tranquility Base, and we have it in New Jersey. It helps reveal the planetary weathering because you get erosion from water, wind, or solar radiation. The windblown sand basically has all the corners knocked off it, so each sand grain is a tiny little round bead. And you can also tell how long the sand has been there, or the regolith has been there, by how much erosion it has suffered. Okay, next. This is wonderful. Secrets in the sand. And even if it's raining and you are at a seacoast, you can still do geology. If you have pink sand, you know it's from microscopic shelled insects. If you have black sand, you know it's from basaltic lava in Massachusetts. And if you have white sand, you know you're at Barnegat Bay because it's eroded limestone. And you can do, you can figure out the mineral composition and do planetary geology right there. Okay, next. Earth is mostly quartz and basalt. Mars is iron and silicon and sulfur and basalt. The moon is the surface is actually regolith, oxygen and aluminum. And some of the places are rich in iron and magnesium. And you gather all that sand and you bring it back and you analyze it. And you can learn a lot about that surface. Okay, next. Sand dunes. Again, they're carved by the wind, whether they're in Australia or on Mars. You can tell how the windstorms have eroded the surfaces of all the planets and by the seacoast. All right, next. And before I close, I want to thank my parents who taught me to appreciate science, and they loved the 8th Avenue beach at Belmar. And I want to thank Al and Mary, and now John. And I want to thank NASA and Mars Reconnaissance Orbiter and the 2 Voyagers. And one more slide. Okay. Hit it again. There should be something coming up. All right. The larger the island of knowledge, the longer the shoreline of wonder. And I thought that was a wonderful quote to go with this presentation. And John, I must thank you again.
You're welcome.
And that's it, folks. That's it.
Hey,
Oh,
thank you, Bonnie. Anybody have any questions?
you heard it before.
I have a comment. I did some astronomy by the shore when I saw
Good.
the total eclipse of the sun from Aruba on the beach. That was fun.
Yes, we saw that too. We went to Aruba and saw it. What year was that?
98.
1998. Yes, we did.
And on the
And I
way,
think-
the captain turned
That was
off
the
the
only
lights on the
people-
front of the boat, and I saw Omega Centauri with binoculars.
Oh, wow. Wow.
That was good.
I think Al and I are the only people who went to Aruba and deliberately did not bring bathing suits. But I also remember Al setting up his camera and and taking pictures of the sun like 2 days before the eclipse, right at the in front of the hotel. We stayed at the Howard Johnson's, and the ocean was right there.
Yep.
So he sets up his camera and tripod, and people are coming over. Oh, what are you doing? Taking pictures of the sun. Oh, that's interesting. Well, I'm practicing for the eclipse in 2 days. What, an eclipse? What eclipse? Oh my God. They just happened to pick that week And those days to visit Aruba and had no idea what was happening.
Yep.
I also remember that Al brought slides, old-fashioned Kodak slides, and was going to do a presentation on Tuesday morning at the Howard Johnson's. I think the eclipse was Thursday. So Tuesday morning, Al was doing a presentation in their little meeting room. And the idea was to inform the staff. In case the tourists had questions, the staff would have some basic information and explain what was going on.
That was
But
nice.
it turned out that hardly any staff came to the meeting. It was mostly guests who had no idea that there was going to be the eclipse. And a lot of AAI members who attended stood on the back wall. So we gave up our seats. And there were like 65 people in this meeting room. And Al gave a slide presentation and explained what an eclipse was, what to expect, how to photograph it, all that stuff. And they were thrilled. It went very, very well. I was very happy Al did that. The slides took up a lot of space in our luggage, but I'm glad it worked out great.
Okay, I'm going to stop the recording.
Good night, everyone.